In this video, I am going to solve the problem 63rd from chapter 17, Waves Part 2. A well with vertical sides and water at the bottom resonates at 9 Hz and at no lower frequency. The air-filled portion of the well acts as a tube with one closed end, which is at the bottom, and one open end, which is at the top. The air in the well has the density of 1.1 kilogram per meter cube and the bulk modulus is 1.33 multiplied 10 power 5 Pascal. How far down in the wells is the water surface? So what they gave in the question? There is a well, and this well with vertical sides and the water at the bottom of the well, and which will resonate at the frequency of 9 Hz. There is no other frequency. So we have to consider only n is equal to 1. Okay. The air-filled portion of the well acts like a tube. You have to see this figure. So this portion, the water surface, is considered to be a closed end and the open end is exposed to the air. Clear? That means this well is act like a tube which one end is closed by means of water and another end is open, which is exposed to the air. And here the density of the air is given as 1.1 kilogram per meter cube and its related bulk modulus value also given, which is 1.33 multiplied by 10 power 5 Pascal. Now what we are going to find from this question, we are going to find what should be the distance from the top to the bottom surface. The bottom surface is nothing but the water surface. Clear? So that means we are going to find the value of the D from this diagram. So here in the right hand side of the diagram, I just draw this well as a horizontal view. And here this well emits the frequency. Am I right? So only one frequency, which is and it has no other frequency. Am I right? So that means it has only one loop. So that means at the closed end you have only one nodes, which we already studied in the theory, right? So now we are going to find what should be the value of the D. As we already know, if you have the half of the loop, you have only quarter of lambda, right? So therefore, the distance of the well, which has only lambda over 4, therefore lambda, which is equal to 4 multiplied by D. So this is the lambda value for this case. Clear? And what is given in the question? Its related frequency. That means that its resonance frequency is given as 9 Hz, and the density of the air is given as 1.1 kilogram per meter cube, and its related bulk modulus value is 1.33 multiplied 10 power 5 Pascal. Now what we are going to do, we are going to find what should be the distance from the top to the water surface. That is our aim. So for this, I'm going to use the basic formula, which is speed, which is equal to frequency multiplied by lambda. So I'm going to rearrange this equation in terms of frequency. Therefore, frequency, which is equal to speed over lambda. Now what I'm going to do, I'm going to apply the rule for the speed. Actually here in this question, they gave the value of the bulk modulus as well as the density, and we studied this formula in the theory chapter 17, which is a speed which is equal to square root of the bulk modulus of the material over the density of the material, right? So I'm going to substitute this formula here. Likewise, the lambda, for the lambda, because this well resonates at frequency 9 Hz, am I right? So I'm going to substitute the value of the lambda as 4D here. So by that, this equation will become F, which is equal to square root of B over rho over this lambda value is 4D. Now we are going to find the value of D. So I am going to bring only the D to the left hand side of the numerator. By that, the equation will become D, which is equal to square root of bulk modulus over the density over 4 multiply. This frequency will come to the right hand side of the denominator. So by that, it becomes 4 multiplied by F. Now I'm going to substitute the value because we have all the values. So let's substitute one by one. What is the bulk modulus of this material? The bulk modulus of the air? They mention 1.33 multiplied 10 power 5 over the density of the air. They mention here as, what's the value? The density here is 1.1 kilogram per meter cube, right? So 1.11. sorry, 1.1 over 4 multiplied by the resonance frequency is 9 hertz, right? So I'm going to find the answer now. So I have to use my calculator. First of all, I'm going to find the numerator. What is the value in the numerator? Which is the square root of 1.33 multiplied 10 power 5 over 1.1. Actually, I got 347.71 over 4 multiplied by 9 is nothing but 36, right? So now I'm going to divide this value. So therefore, 347.71 over 36. The answer for the distance is 9.658. So I can write the value as 9.66 meter, right? So this is the answer for this question. Clear? That's it. Thank you.